Hello, my name is Mike Wa Nkongolo. I'll be presenting the PhD entitled Ensemble Learning and Genetic Algorithm for the detection of novel nitric anomaly using the UGRansome dataset. This PhD was supervised by Dr. Jacobus Philippas van der Venter from the Department of Informatics at the University of Pretoria and Dr. Sidney Mike Wa Nkongolo from Stellenbosch University. The problem addressed in this research is to safeguard organization against malicious network attack because conventional methods that recognize those type of attack are ineffective due to the lack of well-designed datasets which are required to train and test intrusion detection system. Existing machine learning algorithms are used by intrusion detection system to identify novel malware attack also struggle with low efficacy in terms of accurately detecting and classifying zero-day exploits of network threat. And then the main concern is the lack of sufficient feature extraction and feature engineering or of property of novel network intrusion, which make it difficult to build the dataset. So the primary objective of this research was to develop a dataset to prevent a non-threatening behavior on the network. So the aim was to assist network operator to enhance the security of their network. So the research demonstrates the dataset efficacy in using its most critical attribute to create and apply shaping and filtering rule in real time on the network to block malicious intrusion. So the dataset has been used to block malicious intrusion in real time. So the process resulted in effective blocking of malicious traffic, which actually surpassed or outperform existing ideas, dataset, and methods. So the challenge that we address, we actually integrate similar and diverse datasets to build the final datasets. And we also identify most relevant features in this process and also achieve the dataset balance. Then, when we had the final dataset, we employ different training and testing techniques to assess the accuracy of different machine learning algorithms. And the methodology used in terms of machine learning classification was an ensemble learning, which is actually an hybridized approach that amalgamates ensemble learning model for classification and prediction and genetic algorithm for feature selection. The best performing algorithm was random forest, which achieved 99% of accuracy. So the study used a design research approach. We use the UGRansome dataset and the ransomware dataset. We combine the two datasets to build the final dataset, which we call the UGRansome dataset, which is the main contribution of this research. The technique used in building the UGRansome dataset, we call this technique Fuji merging because it is based on randomly shuffling and merging features which a specific similarity, whether it's high, medium, or low. And the results, the study created a data set, which is the main contribution to the fuzzy merging approach and provide different data analysis results. And the impact of the UGRansome data set is noted, which actually block different malicious traffic on the network. We also compare the results with existing studies. And when it comes to techniques and tools, we use multivariate analysis using Python and R for data science. We employ dimensionality reduction using principal component analysis and data cleaning and feature engineering. The feature selection approach was the genetic algorithm. And we use different visualization technique to represent the data insights. And to test the dataset in real time, we use the PRE module of a deep packet inspection system. The PRE module analyze the traffic that bypass a network and classify it according to whether it's going to be an intrusion detection or not. So the PRE was the main module to test the dataset in real time. The dataset was implemented in the core network, and all the traffic bypassing the core network has like a template matching function which determine whether the traffic is positive, is determining whether the traffic is normal or abnormal. So the dataset was used to filter the network traffic in real time through the PRE module of the deep packet inspection system. This is the type of traffic that bypass the PRE. We can have YouTube, Netflix, Facebook. But if this traffic is malicious, then the dataset can be configured to block the traffic. So in the channel area of this representation, this is where we actually implemented the datasets with various policy to filter and shape, or even to drop or reject the traffic according to specific rules or characteristic within the dataset to determine whether the traffic was a malicious flow, normal flow, or unknown flow. So this is the UGRansome features used to perform the filtering and shaping or rejection of traffic in real time. The timestamp, the protocol, the flag, the family of the attack, the cluster, and the port, the treat, even the prediction, which are classified into anomaly, signature, and synthetic signature. So this is the characteristic of the dataset. Originally, it is redundant with 28% of duplicate features. And then after data cleaning, we have 0% of duplication, and the number of row decreases as well. So the dataset was evaluated using different machine learning algorithms. This is the sensitivity results showing 100% of accuracy. And this is the prediction of the decision tree algorithm predicting different network attacks. This is the results showing the performance of the machine learning algorithm used. We are comparing different machine learning algorithms, the extract tree, decision tree, random forest, and XGB boost. And it can be seen that the ensemble learning XGB boost outperform the other algorithm in terms of precision, recall, F1 score, and accuracy. We also had an expecting anomaly when testing the dataset in real time. We could see that we had an issue of packet drop. When testing the dataset in real time, we lost some packet for unknown reason, and this can be investigated further. This research has been published through 4 journal articles, which are actually available from 2021 up to 2024. We published 4 journal articles, which are actually available online. Thank you very much for your time.